Hello, my name is Emily Spicer. Said that like 20 times in the last hour, so hoping this is the last one. My mom's laughing behind the camera. This is it. So, I was part of the group that proposed a conceptual design for a nuclear powered fishery last semester. In case you don't remember, don't worry, I'm going to catch you up really quick right now. So what we decided on last semester was we have a fishery on one side, we have a nuclear power plant on another, we've got a fence in between them. What we're going to do is we're going to have the fishery pool water being pumped to a heat exchanger. The other side of that heat exchanger, we're having a plant connection, and that's getting pumped. Wastewater from CCW is getting pumped to the other side. This is giving us enough heat so that we can heat our fishery pools outdoors in Canada in the winter. So we thought that was pretty successful. It's a pretty good success story. We all went about our different ways second semester to produce detailed design packages for this idea. My specific detailed design package, what I'm going to be telling you about today, is the pool and interface design. So our client specifically asked for our fishery to be located with a newly constructed nuclear power public information center, and this was to bolster the image of the nuclear power and to associate nuclear power with existing in harmony in nature, because we know it does and we want the public to also know it does. So how I did this, great question. I followed the design process. So very similar design process to what we did first semester, but I'm gonna jog your memory really quick. First, I started with my design inputs, the most important part to the design process. So I defined assumptions, requirements, and the preliminary information that I needed. My assumptions were mainly based on my bounding conditions and adding enough margin into all of my information to make sure I have very conservative calculations. We did not want to be killing fish under any circumstance. So there were things like how cold I could expect it to get in the winter, how warm I could expect it to get in the summer, how many fish I could expect to die. So we wanted to make sure that we could always meet our production targets. Our production target is 1,200 tons per year. So we made sure to add lots of margin in these types of calculations. I also assumed that all of our licensing and permits would go through. Then we have our requirements, all of the different types of requirements you can imagine, maybe some you couldn't even imagine. Most of them were based directly on either the pools or the interface, and most of them performance-wise were how to make sure that our trout have habitats that are providing safe and healthy environments for them to grow large and fast in, and making sure that the client is happy with how our fishery interfaces with the Nuclear Information Center. So we wanted to make sure there was lots of visual aspects, lots of visual ways to learn about trout and how the nuclear power plant is helping these trout grow. And then lastly, we've got preliminary information. So it's just, again, how can we make sure trout are growing well, and basically our conceptual design from first semester, obviously very important to carry into second semester. Once we were finished with our design inputs, we took all of that information and we thought of all of the different ways that we could make this work. So we had a lot of different design choices, things about the pools. Are we going to have one big pool, little different pools? You'll find out, don't worry. How many windshields do we need? What kind of windshields do we need? A big thing that we learned from first semester is that most of the heat transfer is due to forced convection with wind. So we wanted to make sure that in times where we were worried about how much heat that we were losing, we can make sure there's no wind and we can eliminate that heat transfer method. And then how can we interact with the public, with the fishery still being safe and commercial, and the information center still getting enough visual on the fish to promote what we needed to promote. So we have all of our different choices, and what we did was we made decision matrices, and those were based off of absolute must requirements, which is how we made all of our decisions. So our final design, I'm going to describe it to you quickly now, and then you can see all the pictures in a second. What we decided on was 3 pools, outdoor, in ground. They had a concrete liner, and that was lined with epoxy, so it was nice and smooth, good for harvesting, good for maintaining. These were connected underground by shafts, which could be opened or closed, so we could operate either as one big pool or 3 individual pools, depending on what we needed for that day. So then we have a 4th area to grow fish. This was much more temperature sensitive, so we've located the hatchling pool actually indoors. It turned out it needed a much, much smaller volume, so it was very easy to locate indoors. And it was a good visual. It added a good visual to the information center, and it would always be indoors, so they'd always have some kind of live visual, no matter the season, if it was unable to go outside. Then for our windshields, we decided on seasonal shelters. So they're metal frames, and then they have transparent sides to them. These sides, when not in use, are able to be pushed down into the ground, and when they need to be in use and we need to block wind, they're able to come up. You're able to see through them, so you can still walk outside if it's weather appropriate and safe, obviously. And these were a great way to make sure that we weren't losing all of the heat that we needed in the winter. And then lastly, how are we going to make sure that all of the fish are visible to the information center visitors? So 3 ideas were proposed to the client, and the client liked all 3, so all 3 were implemented. We have underwater cameras, 1 in each outdoor pool, and we have 3 different screens inside our information center, and they have live feeds. This was actually turned out to be a great idea because then no matter the weather, people can see all the different ages of fish, which is a great learning tool. We also have seasonal walkways, so when it's nice out, you can walk around the different fish pools. Hopefully it'll be nice enough that we can have the seasonal shelter walls down and you can see directly in. You can walk up to them, you can see them. There's railings around all of them for safety, but you're able to actually see in and see the fish physically. And then we have viewing windows in case it's not so nice out and you don't want to venture outside or it's not safe to venture outside. So we have 1 above ground and we have 1 below ground. The biggest pool for the growing fish, one side is a shared wall with the basement of the information center. It's completely transparent, and it sort of acts like an aquarium. If you go down to the basement, it's like one big aquarium wall, so you can always see the live fish that way as well. So there ended up being a lot of different ways to see fish no matter the weather. Obviously, all of these decisions were backed up with technical support, so there was lots of calculations done, heat transfer calculations, snow loading calculations. There were temperature gradients in the soil, temperature gradients in the water. There was a lot to be considered. Material selection software was used for the types of windows that were appropriate for aquarium walls. We had 3D modeling of the different aspects, which you'll see in 1 second, and then there is a quick economic overview to make sure that how the fishery was proposed to be functioning would actually bring in business and it could be operated commercially, which was the request of the client. So one of the other large parts of an overall design process is quality control. So overall, we did take the same sort of structure that STF designers had been using in first semester, and we had peer reviews before deliverables, we had communal requirements, we had a shared drive, so information was available about all different types of design packages to everyone if they needed to make sure that things weren't contradicting, and then we had scheduled team meetings. This is the visual representation of the pools and shelters. So these are the 3 pools that are outdoor and in ground. We can see the underground shafts here where the fish are able to move through them when harvesting is complete. So we would harvest all of the fish here, move all of the fish in this pool over, move all of the fish in this pool over, and then manually move all of the fish from our indoor pool, which is right here, to our frag pool. This is the hatchling pool. You can see that it's completely transparent, so visitors are able to see. All of the edges are rounded to make sure that it's child friendly. And then we have our seasonal shelter here, so you can see, if you open up my PowerPoint file, probably a little bit better, but you can see that all of the glass windows and glass walls and windows are in place, and this is in its winter mode. Now we have the interface outdoor layout. So we have the building here, we have our 3 pools we've already talked about, and then we have our seasonal walkway. These are just 2 little inclines, little bridges, because we need the piping inlet and outlet for the fingerling pool to be able to be accommodated. And then we have a little shed for our equipment storage. That's where all of our harvesting equipment goes. We're harvesting using large nets, so the nets can be stored in here. Other testing things can be stored in here, chemicals if necessary and if safe, so lots of storage overall. And then we go into our indoor interface. So this entire section here is reserved for the nuclear information portion. The nuclear partner is going to be able to pick whatever they deem necessary for the public to see over in this area, and then the other area is all our fishery interface. So we have some areas that we've already talked about. This is the hatchling pool that will be transparent, nice in front and center, make sure that it's very visual. Then we have this window here. So this window is the above ground viewing window. Then we have stairs that will bring us into the underground viewing window. We have this partial wall here. You can see the gray areas are actually all the screens that our live feed will be coming in on. And then all of the pink areas are areas where we can have permanent or take-home information. Going to be all child-friendly and adult-friendly, so you can have pamphlets that have more technical information. You can store maybe in by the doors. We can have things like coloring books and activity books that teach people about the trout life cycle and how nuclear power can interact with that trout life cycle and still be a safe and healthy option for food. And then we have a staff-only area over here. It has offices, it has PPE storage, it has chemical storage, so everything that needs to be not accessible to the public but still very necessary for us to function properly is located over here. So this is the interface indoor layout. And then, so that was basically my final design. After making this presentation and going through the entire process, there was a bit of a reflective part. What kind of things did I learn over the semester? Some things were very technical, some things were less technical. I'm sure some of the extremely technical things I might not be taking very far into my career, like all of the information I learned about rainbow trout. But I will take a lot of other things with me. So I learned a lot of things about teamwork. I learned a lot of things about time management, about myself and how I manage my own stress and my own responsibility that I've taken on. So there's a lot of things here. Some of the things I've gotten to review from things I've learned in my undergraduate. I got to review heat transfer. I got to brush up on my modeling skills, my 3D modeling skills. I learned new things. I use things that I've just learned this semester, like material selection software. And I've also learned things that I will take with me no matter what industry I end up in. One day, I learned how to know when I need to ask for help and how to ask for help effectively. I've learned a lot about communication skills and about collaboration with others, and how to manage my own expectations of myself and others. So I don't know, I probably didn't hit on everything I have in here. I learned a lot this semester, but everything in here is important. So yeah, it was a great learning experience overall. But you don't learn without hitting some bumps. So these were the 3 challenges that I would say were my biggest over the semester, and these are how I dealt with those things. The first one was incorrect work from last semester. After sitting down and ramping up on second semester capstone, I realized that some of the things weren't quite adding up from first semester. Some of the math just didn't make sense in my head anymore. So I had other people look at it, and then after it was confirmed that it was not so correct, I dealt with it by editing and version control. So I was able to redo calculations, revved up our document, let everybody in my team know, so we were all moving forward with the same numbers. So that was a good lesson in version control, and it was very useful to help me overcome that challenge. Second was collaboration. Obviously, in final year university, not everybody has the same sleep schedule, not everybody has the same work schedule, but our team was able to overcome people working at different paces and different times of the day and everything with really just effective and constant communication. So I found that to be very useful. And then the last challenge overall was confidence. Going into this semester, it's very intimidating to go from having an entire group project where there's a lot of people collaborating to it's all your own responsibility and people are there to support you, but it's just not the same level anymore. So I was nervous about me not having the skills I needed, and I found that I was able to overcome that by practicing the skills that I was nervous about and allocating myself tons and tons of time to work on the things I was uncomfortable with. So that was a good way to overcome that. For example, 3D modeling, very, very nervous at the beginning of the semester, but allocated lots of time and I was able to relearn a skill that I can take with me out of graduation. So that was a happy ending. Yeah, those were the challenges and how I overcame them. And then overall, I just want to say thank you so much. Thank you to my supervisor, John Froats. I learned a lot about fish this semester, but I also learned a lot about the design process and about collaboration, and I would not be able to say that this was a success without you. And I consider it a success because my design met all of my requirements at the end of it. So almost forgot to say that. But yeah, so thank you to my supervisor. Thank you to all of the profs that have helped me along the way. I use so much of what I've learned in my undergrad, and I wouldn't have been able to do it without that. And then lastly, thank you to my STF design team members, because we wouldn't be here without all of the pieces of our puzzle. So thank you so much, and thank you for watching, and I'm so glad I got this all in one take.